So thank you very much. I want to thank the organizers. This is a wonderfully organized event, conference, and certainly in one of the world's great cities in a beautiful time of year. We're seeing a range of weather. I'm from a part of the world where we see ranges of weather, and I love it. And we're also at a world-class university, so this is wonderful. It's also nice to be at a conference where we're actually tackling hard problems. Most of my life as a scientist engineer, we talked about positive results. Here we verge on the less positive side sometimes, and this is difficult to have these conversations as scientists. But we have to keep reminding ourselves that this strengthens our work. And also, as was pointed out yesterday, and maybe even today, some of this is politically fraught in the sense that there are things that are going to be said at this conference, maybe even by me, that if taken out of context won't go well. But frankly, if you've not been quoted out of context, you probably haven't been quoted enough. So a little bit about me. 4 decades ago was the first time I went into the lab as an undergraduate. 3 decades ago, I got a faculty position. 1 decade ago, ballpark, I got this job as a vice president for research, and have slowly moved from being in the lab 100%, as well as teaching, of course, to a position where it's 100% on the administrative side. I oversee strategy for the university to move forward, and I oversee operations, sponsored research, IRB, IACUC, conflict of interest, export controls, research safety, and of course, research integrity office, where we have a robust program where we deal with training and, of course, handling of allegations and inquiry and investigations. So I take an institutional view on everything that I do. What you see here is a view of the university from our Evanston campus, 1 town north of Chicago, looking at our downtown Chicago campus. We were in the northwestern part of the country back in the 1850s. The country moved, expanded a little bit further out to the west, but we didn't. We stayed right where we are. So that's why we're called Northwestern. We were in the Northwest Territories. There are 8,000 undergrads, 20,000 total students at Northwestern, law school students, med students, business school students, master's students. Of those graduate students, about 3,500 of them are PhD students. And to give a sense of the research volume, this year we're doing about $650 million worth of externally sponsored research, and then we have internal dollars, which frankly we don't count that much. And to give a sense of the scale of that, we've grown 60% in the last 10 years. This is when federal funding in the United States has been dead flat. We've gone up 60%. So it's been a real challenge to keep up with all of this. This is my first World Conference, so thank you, Lex, Tony, and Nick, for inviting me. I've been at US level conferences on this subject. I know Susan and Zoe, those of you know them. They're here, and I'm glad to be part of this conversation, and very important part of this conversation. I'm not sure that I will add to the list of topics here, but given my institutional view, hopefully there'll be a few. You'll see this from my point of view. So let's take a half step back. How do we learn? First thing we do is we're human beings. We tell stories. We gather evidence and we tell stories. We've been doing this for probably forever, as long as we've been humans. It would be good to go forward. Here we go. In the science side, we start building these stories by developing a hypothesis about how the world works. We then design an experiment. We take data, which gives us information, which leads to knowledge and eventually to wisdom. This is an important process and eventually leads to paradigms about how the world works, and it's an iterative process. And it's a process that is not only in the hard sciences, but is also in the softer sciences, anthropology, sociology, economics. My colleagues in these fields tell me about this all the time. So what can go wrong? So we can have inadequate methods and poor data, which yield wrong stories and wrong knowledge and wrong wisdom. We can talk about the FFP side. That's been talked about quite a bit. We can also talk about poor practices. So there are a number of articles that talk about poor practices, experiments not being blinded correctly, not being repeated, experiments where all you hear about are the positive results, not the negative results. Controls that aren't done well, either positive or negative controls aren't handled correctly. Methods and materials that aren't validated. And, of course, statistical errors that are made. And, of course, we all go into this. Every one of us go into everything we do in life with a bias. And there is this paper, which many of you know, that talk about 235 forms of bias. That would be a challenge to present in an RCR course, but frankly, probably ought to be presented in an RCR course so that students and postdocs and faculty understand these biases. These non-reproducible results can also be not due to malfeasance or fraud, but just differences in methods. And I'm reminded by one of my former grad students who has worked with a major computer chip development company, probably one that you have chips from in your pocket right now, that whenever they want to repeat a process, in other words, make a new chip, make a repeat of a chip someplace else, they have a team come into that laboratory and inventory every screw, every bolt, every piece of material in that lab where they're successfully making computer chips so that they can repeat this elsewhere. And if you have to do that in physics, you can imagine the difficulty in reproducibility if you go elsewhere in other fields. Results that aren't repeatable lead to dead ends. And they change people's health practices. Others have talked about the impact of vaccination changes and changes in the vaccination practices of people. They impact our patients, our human subjects who are participants in the research that we're doing in the medical area. And if it's not good results and they end up in a clinical trial and those results don't work out well because of irreproducible results, they feel badly. It impacts researchers who waste their time trying to replicate data that can't be replicated. And as many of you have read, there are companies that are really pretty upset at us as academics, where we produce papers and they can't reproduce the results. Or they can reproduce the results only, for example, 11% of the time. So they come back at us and they're pretty upset. And frankly, I go out and meet with these pharma companies periodically, and this is exactly what I hear. But frankly, it is not just drug companies. This hits home for me. This is a list of drugs that we have in the pipeline. And you can't read this, and I'm sorry, because we have so much going on. But we identify targets. That's the leftmost column. We identify potential drugs or biologics or now nanotechnologies. And then we optimize those, we put them through preclinical trials, we put them through clinical trials, and then we eventually get them FDA approved. In the bottom left-hand corner there, right-hand corner, if you're interested, you can license these and you can see where they are in the licensing scheme. And we don't stop at drugs. We have medical devices, we have diagnostics and biomarkers, we have materials and manufacturing, and we have energy, and we have environmental remediation. All of these assets of the university need to get moved out into societal impact. So, this bold statement at the bottom here, the bolded statement at the bottom here, is that universities also want to know what have value. Because somebody in my position, this is very important. I am putting resources, university resources, into moving these assets along those pipelines. And irreproducible data, stories that are wrong, paradigms that are wrong, affect the bottom line of the university, affect our resources, and frankly, affect our goals. And one of my goals is to get ideas that were developed in the laboratory out into societal use as new products or on the economics and sociology and anthropology side, new policies. So the argument that I hear from pharma companies, that this is a problem for them, I turn around and I tell them, this is a problem for me. So it hits home. Oh, and let's not forget, probably most importantly, our major funders, the taxpayers, certainly for us, the taxpayers of the United States, are not interested in wasting their money on things that can't be reproduced, or more importantly, more significantly, are fraudulent. So, what's the path forward? Here's a brief outline. I'll talk about the education for trainees. This is a little bit of a repeat from what others have said this morning. What funding agencies can do, what can be done at the level of the university, of the schools within the university, the departments within the schools, of the investigators, and then I'll talk briefly about the journals, and also very briefly about root causes of some of the problems. So the path forward, training of researchers. And frankly, this is not the whole answer, but this is part of the answer, and responsible conduct for research training is one obvious part of this, and I say obvious now because previous speakers have talked about this. It's not really about compliance, it's about how you conduct great research. It is well known that you can't do great research if you have research safety problems. It is also clearly well known that you can't have great research unless you have responsible conduct for that research. The training has to occur at the undergraduate level. Maybe that's short and brief because they don't have much time they're spending in the lab. Grad students and postdocs certainly more significant. And this requires the development of courses at each level within each department because there are specificities within each department that are very different. Sociology is very different than physics. But who controls the curriculum? It's not me. We have 90 PhD granting departments within the university. There is no way I am going to understand 90 different fields and be able to have impact, positive, specific impact at 90 different fields. The curriculum is controlled by the faculty. I don't, and I can't control that curriculum. So if we're going to move forward with this, this has to be a team effort. This has to involve funders. This has to involve the university leadership, as was very nicely pointed out. I'm impressed at what you've done in Hong Kong. I am truly impressed. And it also has to be built from the ground up. You have to have the researchers very much involved. And this means your best researchers. And that is not easy. The National Academies of Science in the United States came out with a document within the last couple of weeks, which is going to be helpful. It's called Fostering Research Integrity. This, the change in curriculum, the change in laboratory practices, needs to be driven across the entire system. It's a cultural shift, and we all know cultural shifts are difficult. Now, you all in this room actually play a significant role in this. Many of you are studying this. Most of you are practicing the responsible conduct for research, research integrity. You play this role, and I can see from the organization of this conference that there is a recognition that there are many parts of the science society that need to be involved. So I congratulate you in recognizing that and making it a very visible part of this conference. And my one editorial comment to my colleagues from the United States is that these requirements can't be just from our two major funders, NIH and NSF. It has to be a little broader than that. So what can funding agencies do? There needs to be a robust system for helping institutions through this cultural shift. This is not an us-them situation. This has got to be more about carrots of moving everybody forward as opposed to sticks and driving them forward. And we need a single system for the FFP. That's sort of like base ground zero. I have money from NIH and NSF and Department of Energy and the Department of Defense and the Aeronautic and Space Association, and it goes on. And every one of them handles research misconduct in RCR differently. I go from outside of the Washington, D.C. area inside what we call the Beltway, and I say, I view you as one government. Can you please work together? And they laugh. Maybe you have the same thing in your governments. And again, this Research Integrity Advisory Board was suggested by, recommended by the National Academies as with the goal of improving the research enterprise. At the school level, again, back to positive approaches to RCR training, This requires a little bit of a culture shift that you have to actually give faculty credit for teaching this. What a novel idea that they would get credit not only for teaching in their discipline, but also for teaching an RCR course. And I see a few people smiling in the front row, so they understand that that's actually not simple to do. Provide activities for support for online activities and support for departments developing these courses, and then support for students. So, oftentimes students and frankly also faculty run into research misconduct cases and they don't know how to handle them. For faculty, it is often, if it's a student or a postdoc who's perpetrating a misconduct case, it is often the first time in their career that they're running into this, and they don't know how to handle the situation. It's frankly not easy. So you can sometimes get your best faculty and they come to you and suddenly, as opposed to demanding, they're very much looking for your help, and you have to recognize that. And finally, when we have research misconduct cases, whether it's at inquiry or investigation, my oh my, these cases take a lot of work. Every faculty member I know who's worked on these cases has recognized, has come to me and told me this. And we need to have a way within our system of giving them credit for doing that, because it is certainly not helping their research career for them to serve on these committees. I might have skipped one there. Okay, at the department and investigator level, so now we're at the bottom here at the ground up, and I say that bottom as in the foundation, because this is what all of science is built on. There needs to be culture of nurturing and training of grad students and postdocs. Generally, that exists. But the pressures of modern research put pressure on these grad students and postdocs, and frankly, also the faculty. So there needs to be help for all of these folks throughout there. And frankly, I have known very few grad students, PhD students, who have gone through their training and haven't reached a point of total frustration in their careers. And if you haven't reached that point, you're probably not pushing hard enough as a grad student. So, you reach this point of frustration, and, they need some guiding help to move through that without going down a bad path. So, that requires some building of resources within departments and, frankly, also within schools. And then if you have a student or a postdoc who sees something going wrong, they have to know where to bring that problem, and they have to go there and be able to bring it without any retribution. That is so easy to say and so hard to do, because if you're a grad student in a laboratory with 500 other grad students and you bring forward a problem, everybody knows it was you who brought it forward. It is near impossible to not have that happen. So as an institutional official, I deal with this every single one of these cases. We have to build the support around the grad students or the postdocs who have brought forward problems. And this is not easy. And associated with that is almost always a person-to-person interaction issue. Every one of my colleagues around the country, the vice presidents for research in the United States get together at least once, sometimes twice a year. And this comes up, that interactions between people, in our parlance, human resource interaction issues, are a part of every one of these cases. And helping everybody through that is an important component of dealing with, frankly, research integrity. So, what should researchers do? Again, at the foundation level, researchers are involved and have a tremendous amount of control. Way more control, actually, frankly, than many of us in this room, unless you're a researcher yourself, because you sit on editorial boards of journals, you organize conferences, you're on dissertation committees, you review papers and grants, you're a leader in your professional society, or you're a National Academy member, in whichever National Academy country you happen to be in. And you have an opportunity in every one of these cases, every one of these situations, to bring research integrity to bear. So it's the whole ecosystem that needs to be involved. And finally, what should journals do? So you mentioned this. I agree fully. Journals need to play a role here. They need to correct the literature promptly. I can regale you with stories of calling journal editors and them telling me, we cannot retract the paper unless the author allows us to retract the paper. Okay, you can keep falsified data within your journal then. But I have had that discussion. There also needs to be a recognition that there are various types of retractions. Sometimes researchers recognize their problem, and it wasn't due to malfeasance, it just happened. And they can't reproduce the results, and they need to be able to correct the literature without having this cloud of integrity over them. That is really important, and we need to push the journals to make sure that there are various levels of retractions, and it's made much clearer. Also, the journals are where we, very nicely report our hypothesis, or if you're an engineer, a design, and then do materials and methods, results, and discussion, tell our story. But the journal is therefore the right place to put the data. Now, the journals come back and tell me we don't have the resources to do that. And then I turn to Elsevier and I go, really? If you're from Elsevier, sorry. But, you've already got the materials and methods and the results, and you've already got the results in there. Why not have all of the data in there? I should probably have a question mark in there besides in just videos. Frankly, the video is in there because sometimes you as a postdoc or watching another postdoc in another lab do an experiment, and you realize, aha, that's what they do. They don't shake their cells, they spin their cells. And you go, oh, maybe that makes a difference. Or, wow, they're using a detergent to clean their glassware, they're not using acid. Wow, maybe that's the difference between our results. So these subtle differences are really important. So I'm in the YouTube generation, maybe we ought to go there too. Okay, enough said. Root causes. Berto, you very nicely pointed out that hiring somebody and having a contract that says you have to produce 10 papers in 3 years is not very good, but we hire faculty all the time, and there's an implicit expectation that they're going to publish a reasonable number of papers. And frankly, we bring grad students and postdocs, certainly postdocs, into labs, and there's an implicit expectation of publications there also. So, maybe we have some of the wrong incentives that aren't explicit, as in a contract, but implicit within the entire system. And we need to look at this, and I do not have an answer for this. Because whether you're a key performance indicator or whether you're doing every 3 or 5 year assessment, and certainly as I'm a reviewer on grants, I'm looking at the productivity of the people who are applying. And it's the strength of our system and it's the weakness of our system. People call me for references on other folks, for people who have worked for me, and say, tell me their weaknesses. And I say, I'm going to first tell you their strengths, and then we're going to talk about the associated weakness, because the two of them are linked. So the strength of our research enterprise is that we are tremendously productive. The weakness is the associated drive to actually get publications out and have impact fast. In the medical area, frankly, it's because patients are suffering or dying. And we really, those of us who were, I was in that field for a while, and certainly my colleagues are still there, that's what drives you, because you see these patients on a regular basis, and you push forward. So, we also need a serious and continuing discussion of how to help this situation. I just laid out a few ideas there. How about we start with some data? How big is this problem? There are a few articles out there that talk about, 11% of the results of some major publications were not reproducible. How about we try to reproduce that? And as you're going through your research, so I've had some discussions with folks here in the last couple days who are doing research in this area. What's the hypothesis? What are your materials and methods? What data do you need? And what statistics are you going to use? What are the good research practices that you're using? If we're going to do this open science, maybe we ought to do it introspectively and actually do the open science in this room. And then you're going to get this relationship, but then what we really need is how do you get to cause and effect? So, my colleagues who are in the social sciences are very much driving forward with trying to implement new policies in society, in education practices, for example. And it's great to have a correlation between high income and high productivity in academia, okay? We all know if your parents are really wealthy, then you're probably going to do very well in school. That's great correlation. What's the cause and effect, and can we use that information to get to the situation where we take people who don't have a high socioeconomic status and bring it forward? It's one example of how do you get from, okay, we have knowledge about an issue, malfeasance or whatever, and then how do you get to an effect so that you increase reproducibility and you decrease and then you decrease these research integrity issues. So, last slide. Goal of research is 2 outputs. We have 2 products within a university. One is new knowledge, and the other is graduates. Sometimes the graduates are the most important thing that we do. In fact, all the time. They're the most important thing. They go on for 40 more years and have great impact. We need to be able to trust the new knowledge, and we need these graduates to have high integrity. And that's largely what this conference is all about. So, thank you very much.
Can take 1 or 2 short questions. Let me just ask you one that actually applies to all 3 of the speakers. It's really impressive that you grew by 60% when budgets were flat. But of course, you're doing that at the expense of other people out there.
Yep.
How do you actually set these goals as vice presidents that are going to exceed the funding that people are going to be able to get? How do you go about that?
So the short answer to how we grew is, how did we grow so fast? We were very strategic in resources that we got. And we have built new spaces and have been strategic about hiring faculty who, it takes a lot of work to hire faculty, and we have incentivized faculty hire faculty, so we've incentivized our faculty to hire really good faculty in their area. There's actually not a whole lot of magic to this. We had resources available to us at the university that, let me translate that more specifically. We had money, and we decided that we were going to put that money into a couple of things. One was the research endeavor, and the other one was student aid. Because education in the United States is expensive. We're a private institution, and we have put a lot of money into student aid. So that's the answer to your question there.
Yeah. And it is a private institution as opposed to the big state institutions that you largely compete with in your area.
That's true. And they have been under attack. So frankly, we have had a number of faculty from those institutions who have come to ours and said, can you hire me?
Yeah. I think I'm going to cut off because we're going to miss our break at this time. There is one announcement.
Hang on a second. Why can't I ask a question?
Pardon?
Why can't I ask a question?
Do you have a quick one?
Yeah, I'd like to make a contribution.
Okay,
right?
Go ahead.
It's been very stimulating. It's been a fantastic talk. And one of the key things in it, of course, is the reproducibility of experiments. We're not really getting money to do that. And I think that really that we have to build into what the granting people require is that the reliability of the data that are generated on their grants is supported by not only reproducibility, but by coming at the same target from a number of different directions to support it in different ways. I think that really has to change, and it has to be looked at very hard.
What was the question?
And the question, don't you agree with me in that regard?
Yeah.
And I will give a very long answer. Yes.
Thanks so much.